Martin and I are doing the review questions for Module 13. Martin, please read number 7.
Draw an energy diagram for a reaction that has a large activation energy and a delta H of 0.
Okay, let's just look at these that we drew for number 6. Here we have a huge activation energy, right? And the delta H is not 0, right?
Yeah.
So we want to draw one with a large activation energy where the delta H is 0. Let's take this one and borrow it and erase this one. Since we don't have any numbers, I'm not going to scale it like I did here. Okay, but I'm going to draw it going way up, and then what's going to happen?
Just go right back down
right
to the
back
same
down
place it
to
was.
the same place. Okay, so there we go. A large activation energy and delta H equals 0. Does that look good to you?
Yep.
All right, number 8, moving on.
If you have two 50.0 kilogram blocks of copper, and one is at a temperature of 50 degrees Celsius, while the other is at a temperature of 25 degrees Celsius, which has more entropy? It's obviously the first one, and that's because the entropy of a system increases with increasing temperature.
Exactly.
Okay, on to 9.
What's the symbol for entropy?
Yeah. That.
Yeah. Could we say that then entropy is also a state function?
Yeah.
Yeah, because it.
When you study, your brain neurons store information. This causes the brain to become more ordered. Why doesn't that fact contradict the second law of thermodynamics?
What is the second law of thermodynamics? Let's say
the entropy of the universe must always increase or must always either increase or remain the same. It can never decrease.
Mm-hmm. Okay, so are you sitting in is your body doing anything other than learning?
Yeah.
Your cells are continuing to function.
Yes.
You're burning fuel.
Releasing energy, which causes
You're constantly
entropy.
causing all sorts of chemical reactions
Thinking
to go
and
on.
Storing information causes a release of energy.
Mm-hmm.
And a little bit of energy, but it's only a little bit less entropy in your head. So it causes more entropy around you, and thus balance is remained.
No, there's still a little more than not, right?
Yeah.
Still positive. The entropy of the universe remains positive, okay? Even though you're ordering things in your brain, everything's still falling apart around you.
That's what I said.
Yeah, you did. Okay.
Why
did
you disagree then?
I didn't disagree. I restated it in a different way. We can go to the video if you want. I didn't disagree with you. I restated what you said. Please read number 10.
If a chemical reaction is exothermic but has a negative entropy, what could you do to the temperature in order to make it possible to run the reaction?
So say it again.
If a
chemical reaction and exothermic, negative delta S.
It means its delta S would decrease. So
how can we increase its delta S?
You have to raise the temperature. You say you can manipulate the temperature. Well, by increasing temperature, you increase entropy. So you've got to raise the temperature.
Well, let's look at equation 1313. Okay. Delta G is going to equal delta H minus T minus T delta S. Right?
Uh-huh.
Okay. T in Kelvin. Okay. So if the delta G is negative, then the reaction will be consistent with the second law. So you want a negative delta G, right?
Yeah.
If the delta G is greater than 0, then the reaction can't proceed because it'll violate the second law, right?
Yeah.
Okay. So an exothermic reaction is going to have a what?
Negative delta H.
Right. So if the delta S is negative and the delta H is negative, right?
Yeah.
In order to ensure that the result is negative, we want to make this smaller. Look, the smaller this is, the more likely this is going to be a positive number. We don't know what they are, right? But
Yeah.
if the temperature is high, right,
Mm-hmm.
then you're subtracting a bigger number.
Oh, I see.
Do you?
Yeah.
So if the reaction is exothermic, with a negative delta S, and has a negative S, we can actually lower the temperature in order to make it possible to run the reaction. If you want to, we can go over Gibbs free energy a little more later because I'm not, we'll do that in the practice problems actually, if that's okay.
Mm-hmm.
Yeah. All right. Well, I hope this was helpful for Module 13 review questions. Let me know if you have any other questions.